Hi guys, in this video we will show the operation of the voltage regulator on this Volkswagen Jetta here, okay? So we can easily see that because on this Volkswagen Jetta there is a wire going from the alternator called the DFM, which stands for Dynamo Field Monitoring, and that sends a signal to the engine ECU, okay? So it's a square wave signal that represents the operation of the rotor winding's magnetic field by the voltage regulator. So it's basically switching on and off the rotor winding, which in turn creates the magnetic field. So what we will see in this, when we look at it on the oscilloscope, is we will see a square wave signal. Okay, so when the voltage is high, that will mean that the rotor winding is turned off. When the voltage is low, that will represent the rotor winding being turned on. Okay, so to do this, I have my oscilloscope connected. So I'm basically scoping in here to the alternator, and the wire here, if you can see it, is the DFM wire going from the alternator to the engine ECU. Okay, so first thing I'm going to do is I'm just going to turn on the ignition. So ignition on. Once I turn on the ignition, you should see the signal appear on the screen. Okay, so at the moment, even the ignition on, the rotor winding is being turned on. Okay, so on this screen here at the moment, from left to right, we're looking at a value of 50 milliseconds. Okay, that's 50 thousandths of a second. The voltage has been written from left to right. That's half the time it takes you to blink. Okay, 50 milliseconds. The voltage then is going up, the signal voltage is going up there just over about 11 volts. Okay, alright. So here you can see the rotor winding is being turned on, and here it's turned off. So that's just with the ignition on. Now we'll give it a start next. Hopefully you can still see that. So turn on the engine, and there you can see the rotor winding being operated. That's the voltage regulator switching on and off the rotor winding. So there you can see within 50 milliseconds it's been turned on and off about maybe 8 or 9 times. Okay? Now as I turn on electrical loads, the rotor winding will have to be turned on for longer. So what you will notice is that the on time will increase and the off time will reduce. Okay? So I'll turn on the headlights here first and we'll see what happens on the image. Okay? So headlights going on. So you can see the on time is increasing and the off time is reducing. Now we'll turn on more electrical consumers. So this time I'll turn on the heated rear window, and you can see that the signal is changing. I'll turn on the interior fan, and now you can see that the on time has increased greatly and the off time has reduced. Okay? Now if we could get it to remain on all the time, where you just have a flat line along the bottom, that would mean that the alternator is running at 100% output. Okay? So I'll just see if I can turn on more electrical consumers to get the alternator to go to 100%. So I'll turn on my rear fog light, and I'll put on my brake lights. Now the alternator is running at 100%. The engine ECU will intervene shortly to increase our idle speed. So at the moment our idle speed is roughly maybe 800 to 900 RPM, and our alternator is still running at 100%. Now the engine ECU isn't going to intervene immediately. It might just take maybe a minute or so for it to start bringing up our idle speed. Okay? But at the moment we have what's called an unfavourable charging condition, where the battery is now also supplying energy to the electrical system to allow everything to operate. If it was to remain like this, then the battery will start to discharge. And again, our alternator is still running at 100%. The rotor winding is turned on continuously at the moment. It's on all the time. The magnetic field is always there. And our engine idle speed still hasn't increased. It's still running at 100% on all the time. Now I can hear the engine idle speed increasing, and now it's gone up to about maybe 950 RPM. And now I can see that the alternator is not running at 100% output anymore, because you can see that switching is now taking place. The rotor is now being turned off and on again, the rotor winding by the voltage regulator. So now we're back to a favourable charging situation again, where the battery is now no longer delivering currents to the vehicle's electrical system and can now be recharged by the alternator. Now I start turning off electrical consumers. So I turn off my brake lights, I turn off my fog lights, and now you can see that the on time is reducing and the off time is increasing. I'll turn off my interior blower fan, and now I'll turn off the heated rear window. And now the on time is less than the off time, okay? It's roughly 50, well, maybe about 40% on, 60% off is the duty cycle. And eventually, and again it won't happen immediately, but the engine's RPM, or idle speed, will come back down again. I'll just turn off my lights actually, okay? But again, we're up around 950 RPM, and again that won't happen immediately. It might take maybe up to 2 minutes before the idle speed will return back down to a normal level.